Folks, it's Mr. Wilshaw back with another explainer video. We're looking here at winter 21, question paper 4.2 this time. Got my answers up in the top right hand corner, got my model answer. Okay, we'll try and talk through some of the physics and talk about some areas where we can be careful in our exam. Okay, so let's get started. Question number 3, start off with an electricity question actually. It's quite a nice one to start off with. We're looking here at 4 electrical components and their symbols. Now the thing to recognize here is that all of these components are forms of resistors. Okay, you can see that kind of rectangular box. Okay, now the one that you should instantly recognize is the resistor. Now I probably would assume that most people actually wouldn't refer to this as a fixed resistor, but this is a resistor of constant resistance, and therefore that's why they've called it here a fixed resistor. I certainly have never used that language in my classes. Okay, so just be aware what we mean by fixed means that it's got a constant resistance. Okay, we then got our other symbols here. Okay, and you can see the matching up here. You don't need to, if you look at the mark scheme, it's a fairly okay question to go for here, but let's just talk about the symbols themselves. Our light dependent resistor, it's our bottom one here. The reason it's the light dependent resistor is it's a box with arrows coming in, and those arrows represent the light. Okay, and so therefore that is our light dependent resistor. The thermistor is slightly harder, okay, in my opinion. To me, what this reminds me of, you've got this line going through, and then you've got it kind of leveling off. And what that reminds me of is a temperature time graph. It may not remind you of one. That's a very physicsy teacher thing to say. What we're thinking there is that line of flat, constant temperature when we're changing the state of matter, okay, and then increasing temperature after we've done so. And that's the way I remember it. Okay, last one, the variable resistor, quite a nice one. It's got an arrow through there, and that arrow represents change. We can change the resistance of the resistor. Okay, so only 2 marks for getting that. Okay, you would have had to get all of these to get those 2 marks. Doesn't explain how Cambridge would have marked that without doing that, so we can assume if you didn't get all that, there's a chance you may not have even got any marks in this one. Okay, we're then asked about a thermistor. Okay, now this is fairly typical of CIE. You'll be given a graph of resistance against temperature. CIE uses negative temperature coefficient thermistors. And what that means, temperature up, resistance down. Okay, and so therefore you can see that quite clearly. Now first bit, you're being asked very simply to measure things. Okay, use the figure to state the temperature when the resistance is 5 kiloohms. Okay, you're looking across there, and I make that 32 degrees. Now, we're then asked to calculate the total resistance of 2 identical thermistors placed in series when the resistance of each is 5 kiloohms. Okay, now when we're doing things in series, we're forming chains. Okay, 1 and 2, whoops, wrong way, 1 and 2. Okay, and so therefore we're looking at 5 plus 5 equal to 10 kiloohms. Okay, so simply adding numbers together, and that's why it's a 1 mark question, simply because it's not a particularly taxing calculation. What is more taxing, I suppose, is the next one. We're connecting in parallel. Now in parallel, you may be used to the equation, which is 1 over r, or 1 over rt, is equal to 1 over r1 plus 1 over r2. Therefore, we're going to put our 1 over 5, and we're going to get 2 over 5. Now this is the point where students will often stop. They'll forget to flip it. Well, what we've calculated there is 1 divided by RT. So I've calculated 1 divided by RT is 2 over 5. Well, if I then flip everything above, so I've got RT divided by 1, so RT, is equal to 5 over 2. And therefore, it is 2.5 kiloohms. Now, there's a bit of a check we can do here, but it's not a foolproof one. Okay. I think students, the main thing I find is that students just forget to flip. Okay, now if you have flipped, you want to check your maths anyway. What we want to make sure is that the R value you've calculated, the total current that you have calculated, is lower than one of the individual resistors. So we started with 5 ohms. Okay, you're expecting a value which should be less than 5 kiloohms, sorry. Okay, it should be less than 5 kiloohms. So even if you've done all this work and you come up with an answer with 10 kiloohms, 20 kiloohms, have a little check and make sure that your value is lower. If it's not lower, then you need to go back and check your working because it won't have worked. When you add in parallel, the resistance decreases, and it decreases lower than the lowest of the original resistors. So if you had a 1 kilo ohm resistor in there, the total resistance would be less than 1 kilo ohm. Okay, so just pay attention to that one while we were going for it. Last ones then, okay, and again, one which I think students have trouble with. I don't think students like this particular equation. We've got a fixed resistor with a current passing through it, and you're asked to calculate the charge. Okay, now I try and remember my equations in certain ways, and whilst I was doing this, I kind of come up with a few different mnemonics. One of them, charge is carried over time. Okay, not the most amazing one, but here we're going for charge. CH for charge, C for current, and T for time. Right? Okay, we don't even need to translate that; it's already there. Charge, current times time. Whenever I'm doing these mnemonics, I've got a few of them. I can send links to those videos. I remember them in the equation form, so Q equal to IT, charge, current, time. Therefore, we're just doing a bit of a multiplication, and we're going to get that number 85 at the end. Now, the bit I really want to talk to you about is the fact that this question is 3 marks. Why 3 marks? Well, you'll notice there in the mark scheme, 1 mark for simply doing a calculation, correct calculation obviously, 1 mark for getting the right answer, and 1 mark for having the right units. Now, it would be a very brave person to do this, but if you were to write simply a C there, I think you get a mark, okay? Because you're showing you understand that the units of charge are coulombs, all right? So if you don't know what to do, have a look, see if there's anything you can get. It may be an energy question, you know the energy is joules, maybe a force question, and you know the force is measured in newtons. Obviously, you prefer to calculate the whole thing, but if you don't know what you're doing, no idea, at least try the units. Okay, there's always marks available for you guys. Okay, usual story. If you want more videos, please subscribe to the channel. If you'd like me to post about anything, please let me know. I'm always happy to do so. But if not, no worries. Simply good luck with your physics revision. You're all going to smash it. Thanks for watching.